All right, we are moving on to the last part of this first unit, chapter 5, which is a continuation of quantitative data that is measured. So, the one visual display of box plots, visual display of quantitative data that we did not talk about in the last chapter was a box plot, sometimes also known as a box and whisker plot. And a box plot is a visual display of the 5-number summary. What is the 5-number summary? It's these 5 pieces of information up here. It's the min, the max, and the quarter marks. The min and the max are obviously what they say they are, the smallest value in a data set and the largest value of the data set. The median, or Q2, we know what that is. That is the middle number. Okay. And the median will be marked by the middle of the box, you could say. And then, of course, we know what Q1 and Q3 are. Q1 is quartile or quarter one, the 25% mark, and Q3 is the third quarter or third quartile or 75th percentile, 75% mark. And the way we construct a box plot, notice that the box per se of the box plot, the start of the box is at your Q1, and the end of the box is at your Q3, and your median is in the middle of the box. And then, so the box marks your Q1, median, and Q3. And then the whiskers, you could say, okay, remember it's sometimes referred to as a box and whisker plot. The whiskers go from Q1 down to the minimum, or Q3 up to the maximum. And box plots can either be displayed vertically, as we have an example here. Box plots can also be displayed horizontally. Okay, if you've seen box plots before, you may have seen them traditionally be horizontal, but they can also be vertical. Box plots will also show you outliers. Okay, remember we talked about in chapter 4, outliers are data values that are way off, whether that be way higher or way lower than a majority of the data in the set. So here we have an outlier on the high end that's way higher than the majority of the data here. So a box plot will also show you any outliers, whether that be on the high end like they are here, or you could have outliers on the low end. So that's a box plot. Now, how do we compare histograms and box plots? Because they are two very different displays. Okay, if a set of data is symmetric, okay, so here we have a histogram that is not perfectly symmetric, but is roughly pretty darn close to symmetric. So if you have data that is symmetric, notice each part of the box plot is roughly the same length. Okay, the left whisker, the left part of the box, the right part of the box, and the right whisker. All of those are roughly the same length. Okay, so that is how the histogram and a box plot of a symmetrical set of data will compare. If you have a skewed right set of data, remember skewed right means it tails off to the right-hand side. Okay, so we have here data that is skewed right. Notice the right whisker is longer than the other parts of the box. So in a skewed right set of data, the right whisker, the right whisker will be longer. And the exact opposite is true for data that is skewed to the left. Skewed to the left data that skews to the low end. Okay. Notice here the left whisker is longer in the left is longer than the other parts. Okay, which makes it skewed to the left or skewed to the low end. So that's how we compare histograms and box plots, and that's one of the main parts of the chapter. Examples that you're going to see on your assignment, which, by the way, this will be your first assignment that's on Math Excel. So I wanted to show you an example of what that might look like. Okay, this is a sample question. This is a sample question from Math Excel, where we have 3 histograms, and we want to match it with 3 box plots. In this case, the box plots are vertical. Okay. And you'll be doing something similar to this on your Math Excel assignment on this chapter. So the first thing I look at when I want to match histograms with a box plot, I'm modeling this for you so that when you do this on your assignment, you can kind of take the same approach. So the first thing I look for is for a histogram that is very obviously skewed. Okay. In this case, I notice that this third histogram here, class 3, is obviously skewed to the left. Okay. And remember, I talked about on the previous slide, if the data is skewed to the left, then the leftmost whisker, the whisker at the low end, will be longer. In this case, the one that has the leftmost, or vertical would be bottommost whisker, that is the longest, is class C. Notice on the other, the 2 whiskers are roughly the same length. In this case, the low end whisker, which would be the leftmost whisker, is longer. So class 3, this third histogram, will match with box plot C. Okay. Now, the other 2 are a little trickier. Okay, notice this one is roughly symmetric, right? If I took this bar here and moved it up, and this bar and moved this up, it would be perfectly symmetric. Same thing here. If I took this bar and moved it up, it would be perfectly symmetric. So we're going to consider class 1 and class 2 symmetric. So the way I compare these is I look for where the mode is. So the mode for this one is going to be up here, and the mode for this one is also going to be up here. And I look for which histogram has the longer distance between the minimum and the mode. Okay, so if I look here, the low end is down here. This is the distance between the low end and the mode. It goes from 3 to 5. Okay, whereas this one, the mode is at 6. Notice the low end, the minimum, is at 1. So it goes from 1 to 6, whereas this one goes from 3 to 5. So this one has a longer distance between the low end and the mode. Therefore, that box plot, and we're down to A and B, is going to have a longer left whisker. Okay, which one has a longer left whisker? This one right here. So class 1 is going to go with A, and class 2 is going to go with B. That has shorter distance between the minimum 3 and the maximum 5. Therefore, that will have the shorter whisker. Okay, so it has less distance between the min and the center, which means the whisker will be shorter. Okay, and class 1 has longer distance between the min and the center, which means that whisker will be longer. So to kind of sum up here, the ones that are easy to match up with are the skewed ones. Okay, this one was clearly skewed to the left. Okay, this one, the whisker was clearly longer than the right whisker or the upper whisker. Okay, the other two were symmetric, so I looked for which one has the longer and which one has the shorter distance between the minimum and the mode, the center. In this case, class 2 had the shorter distance between the minimum and the center. So class 2 box plot had the shorter left whisker. In this case, that was B. And then obviously process of elimination leaves you A for class 1 and had the longer left whisker. Okay. Another thing we want to be able to do is we want to be able to generate a box plot on StatCrunch. Now, I am not going to make you draw a box plot by hand when we have the technology that can do that for us. So the way we generate a box plot is by using StatCrunch. Now, remember, I showed you earlier today that if you want to generate a box plot on StatCrunch, you go to statcrunch.com, okay, and you are going to sign in. You're going to sign in with the same username and password that you created for Math Excel. So when you go on StatCrunch, you're going to go to statcrunch.com and you're going to sign in with the same username and password that you created on Math Excel. When you do that, this is what comes up, and you're going to simply click on Open StatCrunch, and it takes you to a spreadsheet similar to Google Sheets. StatCrunch can actually do more than Google Sheets, which is why we're primarily going to use StatCrunch from now on. So what I want you to do to generate a box plot, I'm just going to put a bunch of random numbers in a column. All right, so just put like 10 random numbers. I just put 10 random numbers in a column. Okay. And the way we do this, and it shows this in the PowerPoint, is you are going to go to graph and you're going to choose box plots. Okay. So we're going to go to graph, and we're obviously, since we want to generate a box plot, we're going to create a box plot. Okay. And what you want to do is you want to select the column. Okay. In this case, I put my data in column 1. So I'm going to choose column 1. Okay. And the sort of the standard for box plots is to display it vertically. So if I just choose my column and then click compute, notice it gives me the box plot vertically. Okay. Now let's go to this again. If I go graph and box plot and I choose column, in my case column 1, If I want the box plot to be horizontal in nature, I have to, as it says in the PowerPoint, I have to check the box that says draw boxes horizontally. So if I check draw boxes horizontally after I select the column and then click compute, it will give me the same box plot, but now the box plot will be horizontal instead of vertical. It's really a personal preference. And the cool thing about StatCrunch is now, if I kind of hover my mouse over the box, notice it tells me how many numbers there were. There were 10 numbers. It tells you what the IQR is. Okay. In this case, the IQR was 12. Remember, the IQR is the difference between the first and the third quarter, the 25 and the 75% mark, Q3 minus Q1. And then it gives you the five number summary. It gives you the lower limit, which the lower limit is the min. It gives you Q1. It gives you the median. It gives you Q3. And whoops, what happened here? And it gives you the upper limit or the max. So once you create the box plot, it also will tell you all that important information. It will tell you what the IQR is. It will tell you the min, Q1, the median, Q3, and the max or the upper limit. Okay. So on your Math Excel assignment today, there will be a couple of questions where you have to create a box plot. Okay. So you want to make sure this is how you do that. Okay. So that's how we create a box plot on StatCrunch. Okay. The last thing we want to talk about is shifting and rescaling data. Okay. So what do I mean by shifting and rescaling data? What I mean by shifting data is when we add or subtract the same amount to each data value. So the example that I'm going to use is, let's say I take everyone's monthly cell phone bill in this class and I add the same amount to everyone's bill. No matter how much your bill is, I add, say, $10 to your bill. Okay. That would be an example of shifting data. Okay. When you add the same amount to this each data value, like adding $10 to everyone's bill, everything is going to increase. Everything in this list here is going to increase by that amount. Okay. So if I were to take all of our cell phone bills and find the mean, the median, and all that stuff we learned about in the last chapter, and add $10 to everyone's bill, the mean will increase by $10. The median will increase by $10. Q1 and Q3, the quartiles or quarters, will increase by $10. All of this will increase by that amount. Okay. The things that won't change are your measures of spread. Think about it. If I take everyone's bill and I add $10 to it, each individual value is going up by $10, which means how spread out they are is not going to change. Okay, because I simply took each person's value and I added $10 to it. So things like the IQR, the standard deviation, the range, things that measure how spread out the data is, those things are not going to change. Okay, that is what we call shifting data. Okay. Rescaling data is the exact opposite. So rescaling data is when we take each data value and we multiply or divide those by the same value. Okay, so the example that I'm going to use, going back to everyone's cell phone bill, say instead of adding $10 to everyone's bill, say I decided instead of adding $10, I'm going to increase everyone's bill by 10%. Not $10, by 10%. Well, that means each person's bill is not going to go up by the same amount, because 10% of my bill might be different than 10% of your bill, which may be different from 10% of your bill, so on and so forth. So the point with this is I'm multiplying each data value by 10%, and that's what I'm increasing by. Okay, so I'm multiplying by the same value, which means that the increase, the actual number that each value increases by is going to be different. Okay, so when we do that, okay, everything increases by that amount. So if I increase everyone's cell phone bill by 10%, that means the mean, the median, the quartile, all of that is going to increase by 10%. But in addition, your measures of spread are also going to increase. Okay, the IQR, the range, the standard deviation, they're all going to increase by 10%, because each individual value, okay, is going to increase by different amounts, because we're multiplying instead of adding. Okay, that is what we call rescaling data. So in summary, if I add or subtract the same amount, okay, only these things will increase. Your measures of spread will remain the same. But when you multiply or divide, like the 10% example that I gave, okay, everything, including your measures of spread, will increase by that amount. In that case, 10%. Okay, that is it for chapter 5.